So y'all can thank Mr. Guthrie for today's warm-up question, which says, on average, 1.5 people can dig 4 holes in 1.5 hours. How long will it take one person to dig half a hole? Anybody have any answer to this question? No, it's too early in the morning. My last class had a lot of answers to it. But I said y'all can thank Mr. Guthrie. He changed the question from what I had on there because we changed what we did from last year a little bit. And he thought it'd be fun to give y'all a riddle because this isn't actually meant to be calculated. You can't dig half a hole. You just dig a hole, and a hole is a hole. It could be half as deep, I guess, but it doesn't say that. So you can't dig half a hole. If you dig anything into the ground, of course, that is a hole. Now, if you found a number answer, awesome. But he meant it to be kind of more of a riddle. So anyway, just to get us started with a little bit of silliness before we get into notes that aren't really that silly, but that's okay. We're going to talk about linearization today in our notes. Before we get to those notes, just a reminder, you have a skills review packet that you got on the first day of school that is due on Monday of next week, so hopefully it's finished or nearly finished. But that skills review packet is, again, intended to help you with the quiz that you also have on Monday. In addition, you have a assignment, the second assignment in Mastering Physics in that digital textbook. The primer is due today. Hopefully you already turned in the Intro to Mastering Physics yesterday, but if not, then you're going to want to get that taken care of as soon as possible because it is now late. But your primer is due tonight. And then the mini lab that we did yesterday, that paper is due on Monday as well, because as I told you yesterday, you don't have enough information to finish it yet, but we're going to go over that today. And if you finish it today, you can turn it in. I have a handful of them from my first period class. So some of you may be able to get that turned in today, but if not, you have until Monday. So let's go ahead and get into the notes. Yesterday we talked about, yes ma'am?
Does the packet of math have to be turned in, or is it just...
Yes, you're turning it in. Yeah, the packet is, you're turning it in on Monday. All right, so yesterday we talked about some different types of graphical relationships, and we looked at the shapes of those graphs and how to develop a mathematical model from those graphs and how we could use that. And whenever we have data sets that are more or less linear, okay, if you get pretty much a straight line, those are a lot easier to identify and a lot easier to work with, and you can eyeball it, you can make a best fit line, you can look at how those variables interact, you can make predictions about where that next point might be, okay? But when your data is a curve, which most of the ones we looked at yesterday were, and your data on your lab yesterday very well may be a curve, okay, then it's harder for us to analyze. And so what we do is we need to do a process called linearization. And when we linearize our data, we are able to, one, prove whether or not the relationship we believe to exist between those variables actually does, and two, develop a mathematical model that we can then use in order to answer other questions or make predictions or whatever. But we can get an equation for a line if we are able to linearize it. Okay, and so we can take this data that falls along a curve and go through this process of linearization, and that's what today's notes are for, and that is also what you're going to need in order to finish the lab activity that you started yesterday. That third, number 3, that question with the graph, that's what that is for linearizing your graph. That's why I said you can have your paper out if you like. All right, so here is some data. It says, consider the following table comparing soup sales to the daily temperature. And so we have daily temperatures of 0, 10, 20, and 30 degrees Celsius, and then soup sales, which are higher whenever the temperature is low, and then get smaller and smaller as the temperature increases. Makes sense. I mean, I don't really want to eat soup if it's really hot outside. Okay, and so it seems to be that we have a relationship where when one variable increases, the other decreases. So what would you expect that relationship to be? We talked about 5. Yeah, inverse, perfect. Okay, so I would expect this to be an inverse relationship, which means if I were to graph it, I would expect it to look like which one? 4. Okay, I would expect it to look like 4, an inverse relationship. Okay, now I'm not going to graph that data, but we can graph some other data. So I'm going to ask you guys to go ahead and copy down this data table here because we are going to graph this data together. And you will want to have this to look back at for notes on linearization because it's not exactly the easiest topic. It's not difficult once you get the hang of it, but it does take some practice. So you are going to want to have something to look back at as you're trying to do your own linearization in the assignment today or in the assignments that you have maybe in the primer in that packet. So this one says modify your data according to the model you believe you have. In this example, we suspect the relationship. I gave different numbers, but I still gave one that appears to be inverse, where my x values increase and my y values decrease. So I suspect the relationship is y is proportional to 1 over x. So what you're going to do is you're going to recalculate every data point for x as 1 over x. So because I believe that y is proportional to 1 over x, let's see what 1 over x is, and let's see if y has a directly proportional relationship with that. So right here, if x is 0.5, then 1 over x would be 2. I'm going to add another column, 1 over x, and I'm going to add the value that I get for each row. If x is 2, then 1 over x, 1 over 2 is a half. If it's 3, then 1 over 3 is a third. If it's 4, then it's a fourth, 0.25. If it's 5, it's 0.2. Okay, so you're just recalculating the values for x, and then you can compare those to the values that you have for y. My y values are, of course, in this column here that is in the center now. And so if this relationship holds true, if it is an inversely proportional relationship, then that means that my values for y that I see in my table here should be proportional to 1 over x. This should produce a linear relationship. And maybe you can see it when you just look at the numbers, and maybe you can't. Okay, so what we want to do next is we want to graph it. Okay, so once you have all these values for 1 over x, we're now going to graph y versus 1 over x. So here's all my values. If 1 over x is 2, then y was 4, there's a point. When 1 over x is 0.5, then y is 1, there's my point, and so on and so forth. Okay, so I plotted all of those points on my graph. Some of them get really close together there at the bottom because of the nature of this data. Okay, but when I plot these points, I now have a linear graph, which means I have proved that my y variable is in fact directly proportional to 1 over x, meaning that the original relationship I had was inversely proportional. And this is the same process you're going to go through whenever you do this with your data. Okay, note that whenever you label your graph, your linearized graph, notice my x-axis doesn't say x, it says 1 over x. Now let's pretend for a second this was my temperature and soup sales. Okay, then that means that I would have 1 over temperature here. I would also have 1 over degrees Celsius. And on this axis I would just have my soup sales because I didn't do anything to my y. But you do need to make sure that you label the graph accordingly as well, because this is no longer the graph of y versus x. This is y versus 1 over x. So make sure that your x-axis indicates that. All right, so again, you plot your modified data on a graph to see if it's linear. If so, that means you have confirmed the relationship. So in this example, that means that this is in fact inverse and that y is in fact directly proportional to 1 over x. All right, any questions about that? Okay, let's look at this. Okay, I told you yesterday that sometimes we can't tell which relationship we have. In fact, I'm going to ask you to go ahead and copy down this data as well. The x values are the same, 0.5, 2, 3, 4, 5. But these are different y values than we just looked at a second ago. Okay, and so I can still see that as my x values increase, my y values are decreasing. So I know that this graph is inverse. What I don't know is if it's inverse, inverse squared, or inverse root. And so again, we're going to test it in the same way we did the last one. Okay, so we're going to assume that it's inverse because it appears to be. Okay, and we're going to do 1 over x for this whole column, which these are the same values because you'll notice these x values are the same as they were in my last example. So I have 1 over 0.5 is 2, 1 over 2 is 0.5, 1 over 3 is 0.333, 1 over 4 is 0.25, 1 over 5 is 0.2. But again, I give myself values that I can plot 1 over x against y, and I can see, is this linear? Just like we did before. So we're going to plot it and see, is that linear? Okay, so here is that data plotted. Again, I have y versus 1 over x. You'll notice again that my axis doesn't say x, it says 1 over x. And again, you'll have actual variables, so you'll have 1 over whatever. But make sure that you label it like that. When I plot these, if I try to draw in a line of best fit, this data does not appear to be linear. Okay, now your data is not going to be perfectly linear. Okay, that's never going to happen with real world data. However, there is a better fit for these points. These points don't appear to fall along a line, they appear instead to fall along a curve that looks like this. Okay, so just because you can draw a best fit line doesn't mean you should. Okay, check it and see, is there a better fit? Okay, and this does appear to fit better. So we already know that y is not giving us a linear relationship with 1 over x, because these aren't linear. What does that graph shape appear to show us? Squared, a squared relationship. Okay, so that means that we need to now square all these values, meaning that we're looking at, again, this shape looks like graph 2. Okay, it is a squared relationship, and we're going to go through the process again. We have to complete it again to see if, hey, if we square it, does it now give us a linear graph? Is this an inverse square graph? Okay, so that's what we're going to do. I took 1 over x and I squared it. You'll notice I didn't go back to x. I started with 1 over x because that's the graph that gave me that shape. And so I want to have 1 over x squared. So I'm squaring all these values. This one was 2, well now it's 4. This one was 0.5, I'm squaring it, now it's 0.25, 0.333, 0.111, so on and so forth. So again, you're just squaring the values you had before, and now we're going to look just like we did before, and we're going to see, is 1 over x squared proportional to y? Okay, or is y proportional to 1 over x squared? I guess I should say it that way. Is that going to give me a linear relationship? If so, then I will have proved that I have an inverse square relationship. So again, you're going to plot that data in a graph, or you can just look at it. I said you can eyeball it. Okay, if it is nice and even, it's sometimes easy to see, but sometimes your points aren't going to fall perfectly, and that's okay too. So a graph is always the safest bet, but I can tell just by looking at these points that this is going to be linear. This is 8, this is 4, this is 0.5, this is 0.25. These are all half of this. There's definitely a linear relationship between them. If you keep going, all of them are like that. Okay, so I already know this is linear, but again, best practice would be to actually plot these points and prove it. Because when you get that linear graph, then you know, okay, it was a proportional relationship, and y is proportional to 1 over x squared. I don't think I actually put the graph in here, I just did this. You can graph by hand. These numbers are really small. That's why I didn't do that. You can use your graphing calculator. Or if you're doing it in a homework assignment, Desmos. But I would recommend getting comfortable doing this with a graphing calculator because that's what you would be able to use on a test. Okay, so if you don't have one, you can use the Inspire and try it on that if you know how to do a linear regression on an Inspire. If not, then use your own calculator if you have one. All right, so again, the calculator would be a lot more useful because of how small these numbers are. But this is a linear relationship. All of these have a linear, these are all factors of 2 versus this, so I know that it's going to be straight. Okay, which means that based on the original data we had, which was this, okay, the relationship was in fact an inverse squared relationship. I had to inverse and then I had to square it. So sometimes you have to go through that linearization process twice. If you check the inverse and it's still not straight, it has a curve to it, then you need to see, okay, well, is it inverse square or is it inverse root? And again, you're going to base it on the shape of that graph after that first step in your linearization. What's the shape of that second graph that you got? Okay, and if it was linear, it would have just been this, which we saw the first time. So again, you prove those relationships by linearization. That's how you know. And then it gives you a straight line that you can write an equation for that best fit line. And you can then make predictions for other data points, which you aren't able to do when you're just looking at that curve. All right, guys, so for the remainder of the class period today, you have the assignment 102.2, the primer and mastering physics. That's your digital textbook. That is due tonight. You are welcome to work on that. Or what you might want to do, since it's fresh on our minds and we just went through the notes, is the rest of your lab. Again, you will need to use the notes we just did on linearization to do this third graph. There's not really a spot to do all the math. If you haven't made a prediction yet for number 2, by the way, do that first. Look at your original graph that you had on the front of your paper and figure out what you think the relationship is. If you think it's square root, then you're going to make an extra column out to the side. If you think it's squared, you're going to make an extra column out to the side. But you can add that column next to your original data table on the front. Okay, and you can say, okay, this squared, and then square all the values, and then replot it on this graph. Or you can get a separate sheet of paper, whatever, to do that. But you are going to want to try linearization to prove that relationship on 103. Please check your notes and make sure that you are following all of the rules that we talked about for what a good graph looks like. Okay, that you check those notes and make sure you have all those things on your graph. That way you're getting full credit. Okay, because if you are missing some of those things or don't follow some of those rules, you're going to get points off on that assignment. Another reminder, your signed paperwork is due ASAP, so as soon as possible. If you have the AP letter that you picked up yesterday or any of the papers that you picked up on day 1, you can turn those in up here at the front. Home Access Center, again, and it's actually not in Home Access Center, it's in Class Link before you actually click the Home Access Center button. But when your parent logs in to that account before they click Home Access Center, over all the way to the right, I think, is the button for the lab safety contract, and it has to be guardian number 1. Whoever's listed first on our software is the one who has to fill it out. If you can't figure out, or your parent cannot figure out how to get your safety contract signed, again, the flyer with the instructions in Schoology tells them they can call the technology help desk. They can absolutely do that. But another person that can help them is our campus registrar, so you can have them call up here to the campus and try to talk to her if they're having issues with the help desk. Again, don't forget your skills packet. That paper is due on Monday, and that you do have a quiz on Monday. That quiz on Monday is over the packet, but it's also over today's notes, for example. Anything we did this week is fair game on that quiz because we've been doing a bunch of that math review stuff. Okay, so for the rest of the period, work on one of these things, 101, 102.2, or 103. And if you have questions as you're working, please let me know.